Hello students, you have already studied in trigonometric Fourier series. In trigonometric Fourier series, the equation is basically given by what we have written here. X of t is equal to a naught integral summation a n cos n omega naught t plus b n sin n omega naught t. Now when we are solving this, we have already seen that the numerical has become very lengthy. If you remember last time, the last class, the question that we handled for half wave rectifier, it went on for almost 40 minutes. So what we are trying to do, or what they try to do in an exponential Fourier series, is try to reduce the mathematical load and try to bring it to an even simpler form. So in trigonometric form, we have seen that x of t is basically a naught, then a n, b n, which are basically calculated by these equations. Now these we are planning to change. How? By using Euler's formula. Now we know, according to Euler's formula, that cos n omega naught t is basically given by this equation, e raised to power, so cos theta is equal to e raised to power j theta plus e raised to power minus j theta divided by 2, and similarly sin theta is equal to e raised to power j theta minus e raised to power minus j theta divided by 2j. Then in that case, if you would try to write an equation for a n, then I can write that a n, therefore a n, I can write it as 2 by t, then integral t naught to t naught plus capital T, and now x of t is there, and I am going to now substitute this equation, which has two parts. So basically I will split my integral also into two parts. So x of t e raised to power j n omega naught t, and that divided by 2 I will take outside, and what I do with it you can see it after a little bit time, and then plus, and then again I am going to write the equation 2 by t integral t naught to t naught plus capital T x of t e raised to power minus j n omega naught t, and that divided by 2 I will take, and basically I will cancel off these two 2's, and I will get, instead of that I will get 1 and 1 here. Clear? So now I have got a new form of a of n. Similarly, for b of n also I can write a similar equation where this j is extra, and that j, when it comes out and it is taken at the numerator, it becomes minus j, and instead of plus it is minus here, so that minus is also coming. Now suppose, now I am going to introduce a new value c of n, where c of n is basically e raised to power 1 divided by t integral t naught to t naught plus capital T x of t e raised to power minus j n omega naught t dt. So if suppose c of n is this, you can see that I can substitute this much portion with c of n. Even here I can substitute this much portion with c of n. I have forgotten d of t here, that I will write separately, d of t. Okay, so I can substitute that. The only thing is that here I will have a minus j extra, here. And similarly, if I am going to take c of n, then if I am going to take c of minus n, like this, so minus n means I am going to put a negative value. In that case, this negative, because of this n, it will become positive. That's the only difference. So c of minus n will be this equation, which I can actually replace here as well as here. So what is a n? A n is going to be c of minus n plus c of plus n, correct? And b of n can similarly be written as minus j, this is c of minus n, and this is minus of minus j, which is again c of plus n. So I can take minus j outside, and I will get c of minus n and c of n, which actually if I would write here, there is a small mistake. If I take minus inside, then basically, yeah, it should come like this: C of n and C of minus n, minus of C of minus n. So what I have done, I have taken the minus inside, so this is C of minus n, so that becomes minus Cn, and then plus this minus becomes plus Cn, and that is what has happened here. And similarly, if I am going to look at A naught, then A naught is basically this equation, wherein if in C of n, you put n is equal to 0, then this completely it becomes 1, and what is remaining is basically A naught. So C of 0 is basically going to be A naught, and this information is something that I will now use to rearrange my A of n, B of n and A naught, which is all based off C of n. I can write everything now with respect to C of n and C of minus n, correct? So let me substitute that. So now from the trigonometric form, now A naught becomes C naught plus summation n is equal to 1 to infinity, correct? And then instead of an, I will write Cn plus C of minus n, correct, cos n omega naught t, plus instead of B of n, I will write J Cn minus C of minus n sine n omega naught t, correct? I can write this. So now everything is not in terms of A of n or B of n, now everything is in terms of C of n, but still the equation is little bit big. I will open up the equation, so I can write this as C naught, let it remain there, plus summation n is equal to 1 to infinity. Now I can write C of n terms together, so I will get C of n, and cos is there, so C of n commonly I will take, then cos n omega naught t, and here C of n is with sine, so j sine, so plus j sine n omega naught t, clear? And similarly plus C of minus n can be written with cos n omega naught t minus j sine n omega naught t, correct? So I have opened up and I have rearranged it in such a way that Cn components and C of minus n components are coming together. Now what is cos theta plus j sine theta? Okay, we know that cos theta plus j sine theta is equal to e raised to power j theta, as well as cos theta minus j sine theta is equal to e raised to power minus j theta. This is Euler's relation. Sometimes also students also say that it's Euler's relation. Euler's or Euler's relation. Okay, so Euler's relation basically gives us that. So if I am going to substitute that, then I can say, let me write it as an equation, then x of t is C naught plus summation n is equal to 1 to infinity, and then with Cn I will write e raised to power j n omega naught t, so this is Cn, plus C of minus n e raised to power j n minus j n omega naught t. Okay, so the equation has reduced. Now one more step I can do. I know that e raised to power j theta, here the value of n for for n the values is from 1 to infinity, and since it is minus 1 here, it is minus n here, it means that here the values will go from minus 1 to infinity, correct? And here C0 means the value of n is equal to 0, correct? So I can write this as C0 or C0 plus, I will split up the summation, and I will write this is from n is equal to 1 to infinity Cn e raised to power jn omega naught t plus, now this is where the magic happens, Cn is equal to, I have written 1 to infinity, isn't it? So if I am writing 1 to infinity, and then I am going to write C minus n e raised to power minus jn omega naught t. So this n value is going to come from here. So if I want to take out this negative values, I can put that negative value already in n as minus 1 to minus infinity. In that case, this minus n will become positive and this one will also become positive. So this will be written as this. So here you are having this function and this function, both of them are same, correct? But the summation is happening, on this case it is from 1 to infinity, and here it is happening from minus 1 to minus infinity, whereas this is happening at n is equal to 0. So you are having from minus infinity to minus 1, and then for n is equal to 0, and then from 1 to infinity. All of them can be combined into a single equation now, because now n is going from, all the way from plus infinity to minus infinity, or you can say from minus infinity to plus infinity, and n is equal to 0. All of them, it is going together. So I can write that therefore x of t, the new equation that I am going to write is, it is going to be n is equal to minus infinity to plus infinity, and then Cn e raised to power jn omega naught t. You put different values of n, you can expand it into this form. So that is why I have written this into one single equation, where C of n, and what is C of n? We have already defined C of n as 1 by t integral t naught to t naught plus capital T e raised to, x of t into e raised to power minus jn omega naught t into dt. So now you can see that the equation has been reduced to a very simple form. Into a very simple form. You do not have to calculate all those an, a naught, bn, all those things you need not calculate. You need to calculate only one factor, one particular thing, and that is this C of n only. If you calculate C of n, you can write the equation of x of t as such. So this is what is the exponential form, and you can very clearly see why this is called as an exponential form, because there is no trigonometric values of cos and sine here. Here it is all in exponential form, and exponential form is much easier to integrate also. Cos and sine is little bit difficult to integrate, whereas here you are having very easy parameters to integrate. That is why we basically do this conversion. So let us do yesterday's problem of half wave rectifier and see how this is going to be useful in that case. So find the exponential Fourier series of x of t. The x of t is given here, and I have to find out the solution. So first I will write, as I had done in previous case, for the period from 0 to 2 pi, correct? For the period from 0 to 2 pi, x of t is defined as, so that is a period. So basically it is what? It's a sine wave, isn't it? But half wave rectified. So I will write x of t is having two values. One is, suppose if the height is a, then a sine omega t. So what is omega? Omega is basically 2 pi f, correct? 2 pi f. What is the frequency here? Frequency is 1 by 2 pi. Why? Because the time period is, total time period is 2 pi, correct? So after 2 pi it is repeating. So 2 pi f, which is omega, is 2 pi f, which is 2 pi by t, and t is 2 pi, so omega is equal to 1. So sine of omega t, omega is 1, so it is sine of t. Okay, for t between what? For t, I will write like this: for t greater than 0, greater than or equal to 0, and less than or equal to pi, and between pi and 2 pi the value is 0, correct? So that is what I have basically found out. Okay, and then so from the figure I have written the equation. That is something that you will have to take care. Sometimes you will be given an equation, sometimes you will be given a figure. So most of the time when it's a figure, you have to write the equation just like I have wrote now. And then the period is capital T, which is equal to 2 pi. Therefore omega naught is basically 2 pi by t, which is equal to 1. So omega naught is equal to 1 and t, because these are the two parameters that are equation. Now let me write the equation that I am interested in. The Fourier series, the exponential Fourier series is given by which equation? The equation is x of t is equal to summation n is equal to minus infinity to plus infinity Cn e raised to power jn omega naught t, correct? Where C of n is basically found out by 1 by t integral t naught to t naught plus capital T x of t e raised to power minus jn omega naught t. Okay, so that is also, so this is the equation of exponential Fourier series. Therefore, so let me calculate. Therefore C of n is equal to 1 by t, t is 2 pi, so 1 by 2 pi. T naught is where I am going to start, which is 0. I will start from 0 and go up to 2 pi, correct? Because that is the period. From 0 to 2 pi is the period. And x of t, so x of t, I will write x of t itself, because next step I will split it, and then e raised to power minus jn omega naught t dt. I have forgotten a dt here. Generally I forget, sorry. So therefore, if that is the case, therefore then Cn can be written as 1 by 2 pi, and now x of t is having two values. One is, it is from 0 to pi, and in that case it is, the value is a sine t, correct? A sine t, okay, sine of t, I'll put it in bracket also, let me write it more clearly. A sine of t into e raised to power minus jn omega naught t dt, plus the second limit is from pi to 2 pi, and that is 0 dt. Why 0? Because in that case x of t is 0, so there is no point in writing the other things after it, so that's why. Therefore again Cn, I will write Cn is going to be 1 by 2 pi integral 0 to pi a sine t e raised to power minus j n omega naught t dt. So with respect to dt, I have to solve this. Now here one more thing you will note, that there is omega naught, and omega naught we have already found it to be 1 for this particular problem. So I will write, instead of omega naught, I will put it as 1. So this become jnt dt. Now I have already said sine of theta can be written as e raised to power j theta minus e raised to power minus j theta divided by 2j. I can write that, isn't it? Therefore, from Euler's relation or from Euler's relation, so from Euler's relation, I can rewrite this as Cn is equal to 1 by 2 pi integral 0 to pi a, and instead of sine, let me rewrite it a little bit on top because the page is going to end. So I will write Cn is equal to 1 by 2 pi integral 0 to pi a times, now instead of sine t I will write e raised to power jt minus e raised to power minus jt divided by 2j. That 2j I can basically take outside, so I will get a j here and I will get a 2j. So this 2 will become 4. So this also I will write as 4. Okay, so 2j I have taken outside because it is not a function of t. Okay, into e raised to power, the remaining portion, e raised to power minus j n t dt. Okay, so we have used this formula. So that is the Euler's relation, and we have got this. Now here you can see I can basically take this inside and then solving a little bit more. So let me do that. So I can write C of n 1 by 4 pi j integral 0 to pi, and then the remaining portion. See, in the remaining portion you can see e raised to power jt and e raised to power minus j nt can be written together as, so a also I will take outside. That is one thing that I can do. So I will write a also outside. So a has also come outside. Now what is remaining inside is e raised to power jt into e raised to power minus j nt. I can basically write e raised to power j 1 minus n t. Okay, so what I have done, I have basically taken these two together. I have taken this one inside, I have taken this term inside the bracket, and similarly here I will get minus of, then minus is common, so I will get minus of e raised to power minus j 1 plus n t, that I will put inside the bracket, and then dt. Correct? Okay, so that's how we have got this particular equation. Now this is easily integrable because I can divide it into two parts and then I can do it. So let me integrate it. So Cn a divided by 4 pi j and integral. So integral if I am going to do, then I will get e raised to power j 1 minus n t and then divided by j 1 minus n. Okay, that is the integration of the first term, whereas the integration of the second term is minus, okay, minus e raised to power minus j 1 plus n t divided by minus j 1 plus n. Correct? And I can write the limits. So the limits is going to be from 0 to pi, and similarly here also it is going to be from 0 to pi. and this completely has to be put in a bigger bracket. Another thing that you can notice is that this negative can be taken outside and it will cancel out with this and it will become a plus. So I will take out this and I will write this one as plus. Okay. And then j can be commonly taken outside. Okay, j can be commonly taken outside. So if I'm going to take j outside, then I will get this j, and this j if I commonly take outside, then I will basically multiply it with this j here. So I will do that as a next step. Okay. So let me write again, c of n or cn is equal to a divided by 4 pi, and that j and the j that is inside, if I take commonly outside, it will become minus 1, which I can write it as minus a. Okay, I can write it as minus a, and what remains is within the brackets I will write the first term is e raised to power j 1 minus n pi minus e raised to power 0. Okay, divided by I have already taken n outside, so this is 1 minus n, plus here it will be e raised to power minus j 1 plus n pi minus e raised to power 0 divided by 1 plus n. You know that j has been taken outside, correct? And e raised to power 0 is equal to 1 from where c of n, so c of n or cn is equal to minus a by 4 pi, and now I will write e raised to power j pi minus e raised to power j minus j n pi. Okay, this is all divided by 1 minus n. This is also divided by 1 minus n. Let me write it, draw that line correctly. Yeah, and this is going to be minus e raised to power 0 is actually 1 divided by 1 minus n, plus then here I am going to have e raised to power minus j pi into, so this was into, so I should have taken care of that. So it is into, into e raised to power minus j n pi divided by 1 plus n minus 1 divided by 1 plus n. Which again cn is equal to minus a by 4 pi. Now I am going to join the values and try to see. So here I will get together e raised to power j pi into e raised to power minus j n pi divided by 1 minus n. I am again combining it because another reason, e raised to power minus j pi into e raised to power minus j n pi divided by 1 plus n. Okay, this I will combine together. Okay, and then minus of 1 by 1 minus n plus 1 by 1 plus n, the whole square. Not the whole square, sorry, the whole bracket. Okay. from which you can see that I can take this e raised to power minus j n pi common, isn't it? So I will write again Cn is equal to minus a by 4 pi, then and it will go from e raised to power minus j n pi. I will basically take common, and the remaining portion can be cross multiplied to be e raised to power j pi into 1 plus n plus e raised to power minus j pi into 1 minus n divided by 1 square minus n square, correct? And similarly here I can write minus 1 plus n plus 1 minus n divided by 1 minus n, 1 square minus n square, where this 1 minus n square can be taken outside. So Cn is equal to minus a by 4 pi 1 minus n square, that I have taken outside, and what remains is e raised to power minus j n pi and e raised to power j pi plus e raised to power minus j pi. I have adding up, then plus n times e raised to power j pi minus e raised to power minus j pi. Okay, this is there, so these two are there, and then okay, and then this portion is minus of 1 plus 1 is 2, correct? So 2, and n gets cancelled off, so this much. So now we are moving slightly more closer. The exponential format that you are seeing here, e raised to power j pi or e raised to power j n pi and all, or let me say generally e raised to power j theta. This can be basically written as in polar form as the magnitude is equal to 1 and the angle is theta. Now this is radians, that you should take care. The theta is in radians, not in degrees. Okay, so if you are asking me what is e raised to power j pi, it is as good as 1 angle pi in radians, pi in radians. That is as good as minus 1, and e raised to power j minus j pi is equal to 1 angle minus pi, and that is also equal to minus 1. Okay, so this is generally how we calculate it. So what I would say is the same thing I am going to use here. So I will write C of n is equal to minus a divided by 4 pi 1 minus n square, and then from here it will be e raised to power minus j n pi, that is okay. Now this is going to be, the next part is going to be, this is minus 1, this is also minus 1, so combined it should come as minus 2. Okay, let me write it in black. So this is going to be minus 2, whereas the second part here it is going to be minus 1 minus of minus 1, which is going to be equal to minus plus 1 minus 1 plus 1, which is equal to 0. So this is going to be equal to 0. In previous I had mistakenly written this as 2. Anyway, so this is minus 2 again. So now if I am going to take if I am going to take minus 2 plus 0, it is minus 2, and that minus 2 can actually be taken outside common from here. So minus of a into minus 2, minus of a into minus 2, we all know is going to be 2a. So that I will write here. So 2a divided by 4 pi 1 minus n square, and what remains is e raised to power minus j n pi minus, not minus, plus 1. So minus 2 I have taken commonly outside. This minus 2 and this minus 2 I have taken commonly outside. And now you can see here also, you can see 2 and 4 can basically cancel off. So finally I will write C of n is equal to a, let me take it down, okay, a divided by 2 pi 1 minus n square into e raised to power minus j n pi plus 1. And this equation is what I have to, this is the equation of n, and for different values of n I have to find out what is the value of c. Okay, so now based on this equation I can write at n is equal to 0, I will get C0 is equal to a e raised to power minus 0 plus 1 divided by 2 into pi 1 minus 0, where this is going to be 1 plus 1 is going to be equal to 0. 1 plus 1 is going to equal to 2. So 2 and 2 gets cancelled off and you get a divided by pi. So that is the value of C0. Then at n is equal to 1, or let's say at n is equal to plus minus 1, because I told you Fourier transform and Fourier series are going to be even. So whatever is there in plus 1, that same thing will happen in minus 1. So if I am going to write C1 or C plus minus 1, then here you have a look what is happening. So I will get a e raised to power minus j pi plus 1 divided by 2 pi into 1 minus 1 itself, which actually comes out to be 0 by 0, isn't it? Why? Because this is minus 1 plus 1 gives me again 0 in the numerator, and then in the denominator this becomes 0. So this and this, both of them are basically 0 and 0. So what do? I apply the L'Hospital's. So I apply the L'Hospital's rule. And L'Hospital's rule, basically for that I have to differentiate with respect to n the function that is in the numerator a e raised to power minus j n pi plus 1, this is with respect to n, and similarly the denominator also I will have to differentiate with respect to n, and I will get 2 pi 1 minus n square, okay, which I will get e raised to power minus j n pi into minus j pi divided by, and in the denominator basically I will get sorry, here there is a, I forgot to write a here. So a into e raised to power minus j n pi into minus j pi, okay, divided by 2 pi into minus 2n, correct? From which, which I can further solve it as a minus j a, pi and pi basically gets cancelled, this pi and this pi basically gets cancelled, so those two will get cancelled, and this is minus j n pi, where n is actually 1. This is for n is equal to 1. So this will be e raised to power minus j pi. E raised to power minus j pi we all know is minus 1. So that minus 1 I will write. That minus and this minus will basically become plus. Okay, so I will basically take that out. So a, j, and then pi got cancelled, and then in the numerator we have minus 4n, where n is equal to 1. Okay, where n is equal to 1. So based on that, I will get, so minus 4, correct? So minus 4 minus I will take on top and I will get 4. Therefore C plus minus 1 is going to be minus j a by 4. Similarly, next I can write, or I can find out at n is equal to 2 what is going to happen. And at n is equal to 2, basically again if I am going to look at this equation, then if I substitute 2, then I will get C of plus minus 2. So I am going to write plus minus 2. Again I told you that for the case of this thing I can always take plus minus 2. Either you take plus or minus 2, no problem. So if I am going to take plus 2, then here I will get a into e raised to power minus j 2 pi plus 1 divided by 2 pi n, 1 minus n square, so 1 minus n square is basically 4. So I will get here again, this is going to be plus 1, so plus 1 and plus 1 plus 2, 2 and 2 gets cancelled. So I will basically get a divided by pi into minus 3. That minus I will take on top and I will get pi 3. So like that I can keep on finding the values, and now I have to plot it. So I will plot the first these many values, that is important. So okay, so this is basically Cn, and now I am going to plot for each and every values. So this is at 0. At 0 what is the value? At 0 it is a by pi. So let me draw a by pi. So this is a by pi, so I will write this is a by pi. Okay, and then at plus and minus 1 you are having minus j a by 4. So I will just write the magnitude. The magnitude is basically minus a by 4. Okay, so since it is j, that j part I am not going to draw here, because but I'll just draw it as minus j a by 4. So a by 4 is more than pi, so its height should be less than what we have just now drawn. So let me draw it something like this. Okay, the same I will draw it in minus 1 also. I can draw like this. Okay, so I have got the values. This is minus j a by 4, this is also minus j a by 4, and then the next one that I have got is for n is equal to plus minus 2, which is a by minus a by pi by 3. So minus a by pi by 3 means I have to draw it at 2, so just minus, correct, it is minus. So again I have to draw it in negative direction, so I will draw it like having this much height. So this is our minus a pi by 3. So I will draw, this is minus a pi 3, this is minus a by pi 3. Similarly I can find out for other values like 3, -3, I can find out the values, but I am not going to do it now because that is all that we need. If you want to find, again you can put n is equal to a different value here. Let's say if n is equal to 3, then again you will get basically 0. So like that, its value will be basically keep on changing. You can try to solve it, not solve it, you can try to put different values of n and try to find out the value. But anyway, this is how we do it. Thank you.